So the Pythagorean theorem is like probably one of the most important like geometry formulas that you'll need to know. So let's first consider like a square. So let's draw a square. And now what let's do is let's draw a smaller square inside this square. So let's kind of like draw this square here. So it's kind of like tilted inside. Right? And let's call this length A. Let's call this length B. And let's call like this side length of the inner square, let's call it C. Right? So nothing complicated so far. So so now what we're gonna do is we're gonna derive a relationship between A, B, and C, and that'll give us something called the Pythagorean theorem. So the first thing we should notice is like each of these red triangles, they're each like congruent. Like, and you can kind of like intuitively see that they're kind of like the same shape, like they're kind of the same size. But if you wanted to show that like rigorously, just know that like this outside thing, this big thing out here is a square. So that tells us all of these angles are 90 degrees. And since this inside thing is also a square, we know all of these angles are also 90 degrees. So now if we were to call this angle X, like this angle here, if we call it X, then, and let's call this angle Y. So let's call this angle Y. Then we can say that like X plus Y. So we can say X plus Y plus 90 degrees. This has to equal 180 degrees, right? Because we know that like this is like a straight line. So X plus 90 degrees plus Y must equal 180 degrees. So that tells us that X plus Y has to equal 90 degrees. So that allows us to conclude that this angle here is also X. And the reason that's helpful is because if you were to look at these two triangles, this red triangle and this like green triangle here, we notice they're congruent by HL congruence because they both share a right angle. They both have this hypotenuse of length C, and they both share this angle X. Or actually, you can think of this as AAS congruence, since we have two angles and we have one side. So we know by AAS congruence that these two triangles are congruent. So now we can deduce some more information about these triangles. So notice that if this has length A and the two triangles are congruent, we know that this side length also must have length A. And if this has length B, then this side length here also has length B. So the reason this is helpful is because if we know this has length A and this has length B, then the side length of the big square is going to be A plus B, right? So this entire side length is A plus B. So the area of the big square is just going to be the side length squared, which is going to be A plus B squared. But we can also calculate the area of the big square in another way. We can do it by taking the area of the green square and then finding the sum of the areas of these four red triangles. That's another way to find the area of the big square. So the area of the small square is going to be C squared because the side length is C. So the area is C squared. And notice for each of these red triangles here, the height is going to be B, the base is going to be A. So the area of the triangle is 1/2 base times height. So 1/2 times A times B. And since we have 4 of these red triangles, we just multiply by 4. So we kind of have this like equality. So now if you were to simplify both sides, the left side, you can simplify as A squared plus 2AB plus B squared if you were to expand it out. And on the right side, you would have C squared, and then 1/2 AB times 4 is 2AB. So you can kind of cancel off these 2ABs on both sides. And we can simplify it and get A squared plus B squared equals C squared. And this is what the Pythagorean theorem states. It states that if you have a right triangle with legs of A, B, and C, then the sum of the squares of the legs must equal the square of the hypotenuse. And this is probably one of the most important like geometry concepts that you'll need to know.